So up until now, this is the kind of mathematics we've got the computer to do. So it works. We can do some kind of calculation, and the computer spits out the answer. We know from test cases in advance that it's the right answer, and we're good to go. Problem is, this is only for a radius of 15 millimeters. If I then ask you what's the answer if it's 42, you would have to change your program and rerun it. And then someone says, great, now I want 78, so you'd have to change your program and rerun it, which isn't really helpful. What we really want is a way to get input from the user. But if we're getting input from the user, we need to store it somewhere. And remembering the exact memory location is not a good way of doing it. So in computer science, we have these things called variables. Problem is, you're used to a variable in math class. This isn't math class. And just like the little hat doesn't mean exponent, a variable is not the same thing as it is in math class. Okay? So once again, here's a lovely little link to Wikipedia. So in computer science, a variable is an abstract storage location. Okay? There's a symbolic name that represents where this piece of information is saved. But it's just a memory location that is holding a piece of information. At the moment, let's just assume it's a number. But it's just a memory location. I can change the value of what is in that memory location. So I could put 42 in there, and later on I can say, oh no, I want to put 17 in there now. That's not the same thing in math class. When you have a single equation, x is equal to 7 plus 2, that x is always 9. You can move things to the left and the right side, you can divide both sides by a number, whatever you're doing, but in that single equation, your variable value will never change. Okay, it can't. That's the only way you can solve it, is if it doesn't change. But in computer science, that value can change. So it's just a memory location that we're going to give a name to, and we can put stuff in it. And we can change what's in there anytime we want. Okay? Now, another problem, in math class, someone give me an example of a variable name that you've used in math class for years. Any variable name. X. We use X like all the time, right? And X has a particular meaning. What does it usually mean?
Like a coordinate.
Coordinate, right? There's an X and a Y value. So after years of that being pounded into your head, you know that X, Y is a coordinate pair. If I give you a variable name called Q, what does it represent? What does Q mean? Yeah, we're like, I don't know. If I give you a variable name called R, what does that mean? It usually means radius. So there's a standard in math for these single letters meaning something. Once again, it's a single letter because in math class, you're writing it out by hand historically, and we wanted a short form. Instead of writing out radius, we just say R. Now, on the computer, we have a lovely IDE that will help us out. And if we have already written the variable name once, as soon as we start typing it, it's going to come up in IntelliSense, and we can just press tab. So it doesn't matter about making short forms. In fact, it's a really bad idea to make short forms, because if I'm using Q and you don't understand what Q is, then you're going to be lost. The other problem is we only have so many single letter characters. It turns out we're going to be using a lot of variables. So then people got into, well, we could use like 2 letters. Great, what does like XV mean? I don't know. So instead of using single letters or short forms, whatever that memory location is holding, just call it that. If it's holding area of triangle, literally don't even call it area of triangle. Then there's no confusion at all at what is being held at that memory location. because the name is self-commenting. Anybody will understand that it's area of a triangle because it's called area of a triangle. Okay? So don't try to make short forms. Be as explicit as possible. You will have to type them out long once, but only once. After that, the computer will help you out. Okay? So in computer science, variables usually have a name, and they also have a type. So if I have a variable called radius of circle, like, is it an integer that's going in there, or is it a floating point number that's going in there? Because those are different things, okay? I need a different amount of memory space in the RAM to hold that, so I need to know in advance. So there's usually several types. In Python, they are figured out for us, okay? And we can change the type that's being held in a variable. Maybe it's an integer to begin with, but later on I want to put a float. In Python, that's okay. It's not true in most programming languages. Okay, so when we come to C, you'll see that it's kind of different. So in Python, what does creating a variable look like? Say I want the number 32, I can say age, and then we got to talk about this thing. So once again, in math class, what do we call that symbol? Equal sign. But that's not what's happening in computer science. We are taking this particular value and we are assigning it to this memory location that we now refer to as age. In the back end in Python, the computer is taking that word age and it's actually referencing some memory location. But we don't need to worry about that, it's doing that for us. But it doesn't say age is equal to 32. Equal is an equation where the left side is always the same as the right side, but this isn't an equation. It's an assignment statement. Take this value and assign it to the memory location area. Take this string and assign it to the memory location called sum_words. Now, when you look things up on the internet, when you watch YouTube videos, virtually everybody will say area is equal to 32.45. That's not what's really happening, okay? It's bad form to actually say equal to, but a lot of people out there will. What's really happening is it's assigning it. I could then say area is assigned 42 and change it, but it's not really an equal sign. But you will hear that out on the streets. In here, we will never call that thing an equal sign, okay? We always call it an assignment statement. So we use words and we use the assignment statement to shove some value in. And that's all a variable is. Just a representation of a memory location, and we can use these words instead of worrying about the exact memory location. So that's going to be super helpful, okay? So you'll notice, look here, we took age and then we literally just printed it out. Remember before when we were using print and we did some mathematics in brackets? So this mathematics could now be assigned to a variable, and then we just put the variable name in here. Okay, so using variables is going to become super helpful, just like they're helpful in math class to make your life easier. They're going to become more helpful. So back to this problem. Now we know we can create variables. The next thing we need to do is get input from the user. So I want to get the radius of the circle, right? So it turns out there's a built-in function called input. Notice it goes blue because it's built in. And what you can say is ask the person, enter radius of circle in millimeters. That was nice. Okay? So instead of a print, it's an input, and it will, I'm just asking them for the radius of a circle. Once we get that answer, we need to put it somewhere. We need to put it in the variable, right? So we're going to use the assignment statement, and we're going to say like area of circle. Notice my variable names are just words. They're all lowercase, and each word is separated by an underscore. So that's the standard for Python. That's not necessarily true for every programming language. So on today's website, notice we are using something called snake case, but there are other ways. So any C type language uses camel case, where you don't use underscores. The first word starts with a small and every other word starts with a capital. Okay? If you've done any web design, it turns out kebab case, that's super common in what's called CSS. Okay? So depending on what programming language you're using, there's different rules. That's the rule we're going to use. So if I run this program, it's going to stop here and print this out, and then I get to put the value in, and that value will be placed in this variable. Okay, well, it wasn't really helpful because I didn't like show the variable. So in the output, let's just like print that out. Oh, I forgot the little curly braces. And what is it telling me wrong? Forgot a comma. What am I forgetting here? I forgot the quotes as well. Okay. There we go. Okay, so now when I run the program, it's going to ask for the number, and hopefully it'll print it back. So this is just our variable that's used to hold some number. Okay? Now, if we're holding a number here, we should be able to do mathematics with the number, right? So let's just take this and if we're doing area of a circle, it should be pi r squared, right? So notice that I have the math thing here. So we should be able to do math dot pi times, okay, it's not really area of circle, this is really the radius, right? So I'm taking the radius and I'm squaring it. So let's run that. Ooh. So something went wrong. So when you get errors, it should tell you what the problem is. Okay? So here on line 21, it says unsupported operator type this thing. Okay, so exponent, string and int. So here's the thing. When we get input, the type that it is, okay, remember different types, integers, floats, strings. Since we're entering something on the keyboard, it is a string. Okay, it's words. Because I could have entered Jane Smith, and it will let me enter that. Okay, so it's words. That means this thing is a string. It's a bunch of words. And then down here, I took a bunch of words and tried to square it. Well, you can't take Jane Smith and square it. That doesn't make any sense. Okay, 42 squared makes sense. So we need to make sure the input isn't words, but is actually, in our case, probably an integer. So what we can do is there is yet another built-in function called int. And what int does is it converts words to an integer. I'm just going to place this inside the brackets. And then run my program again. There we go. That's much better. Okay? So input lets you enter in words. Int converts those words to an integer, and then we can do mathematics. Now, doing the math down here is probably a bad idea. We would want to put that in process, like our top-down design, right? It's under process. So we can say area is assigned, and notice it's trying to help me out. And the next one would be perimeter, and notice it's trying to help us out. That helping out came down here from GitHub Copilot, okay? It knows that this is radius of a circle, therefore if I'm figuring out the perimeter, it knows what the formula is, okay? So that's nice. And then here, I could say area of circle is, and then I could just put area in. Oh, notice that's helpful. It even put the squared thing for me. So that's nice. And we get rid of that one. And those ones. There we go. So that's helpful. And we should also do perimeter as well. Okay, so let's check our program now. Let's just clear everything. If we put in 42, it now calculates the area and the perimeter. It'd be nice if we rounded those off probably, right? So we could do that as well. But that's how you work through your input, process, output, and also get input from the user, but also convert it to an integer.